So here now topic is electric potential. Electric potential due to a point charge. Here we in previous video I defined electric potential. Amount of work done carrying unit point charge from infinity to the point under consideration. Work done V equal to W upon Q0, where W is the amount of work done carrying charge Q0 from infinity to suppose P. Then potential here will be V equal to W by Q0. Its unit I told you is volt. If potential at P is 1 volt, it means 1 joule of work has been done carrying 1 coulomb charge from infinity to P. And remember that work is scalar, charge is scalar, so potential is also scalar. Now in this video we will derive as formula how much is the magnitude of potential at point P, which is distance r from point O. O means you can say origin. Origin is the point, reference point, with respect to which we measure distance of different points. So let in figure a point charge capital Q is placed at O. To find electric potential at point P at distance r from O. We consider two points A and B on the line joining the points O and P. The distances of A and B from O are respectively x and x plus dx, where dx is very small. You can say small. Why we are doing like this? Why we are thinking this way? Actually, when Coulomb force proportional to equal to 1 upon 4 pi epsilon 0 q1 q2 upon r square है. Work done F dot d होता है F d cos theta. Theta is 0 और 180 degree here. ना भाई. So now problem that when distance is changing, force will be changing. So here force when charge Q0 is brought from infinity to P, there will be a sufficient variation in the force between the charge Q and Q0. So in this case we have to calculate work done against variable force. For variable force there are different methods of calculating the work done, and the simple method here is integration method. So we have taken point A and B at distance x and x plus dx. dx is small, so whatever the force on test charge Q0 at point A, the same will be at point B. Now you may think that the distance change, there is change difference, so difference of force is there. the difference in the force on test charge Q0 at point A and point B will be so small that we can't resolve the difference. Like you measure the weight of your body on ground floor of your building and then weigh your weight on the top floor of building. Your machine cannot tell the difference. You will get the same reading. The same way dx is so small. Dx is small, where dash is small, is so small that there occurs no variation in the force between Q0 and Q while carrying from B to A. ठीक है भाई? So now force suppose है ना, तो force on test charge Q0 due to charge Q at points A and B has same magnitude. That is F is equal to 1/4 pi epsilon 0 Q into Q0 upon x square. Dx very small. अगर you open whole square, you write x plus dx whole square. So dx is negligible there, and you will find no difference. Direction of this force. Is along OA direction, away. We can write here in terms of unit vector, but I avoid here. So work done in moving test charge Q0 from B to A, dW is equal to FD cos theta. How much is theta here? BA the displacement D and force is this way. So here you can write it as 1/4 pi epsilon 0 Q0 upon x square or into dx cos 180. I should write here dx cos theta. Cos 180 minus 1. So it is minus 1/4 pi epsilon 0 Q0 upon x square dx. This is the amount of work done in moving test charge Q0 from B to A. But to calculate potential, we have to calculate the work done carrying unit charge from infinity to P. Therefore, work done in carrying charge Q0 from infinity to P, we integrate dW within limits infinity to R. That is W is equal to integration infinity to R. What is W? Work done in carrying charge Q0 from infinity to P, dW, integration infinity to R minus 1 upon 4 pi epsilon 0 Q0 upon x square dx. In integration, these things constant, they can be taken out. So W is equal to minus Q0 upon 4 pi epsilon 0. Integration infinity to R dx upon x square. You have learned a formula of integration x to the power n dx equal to x to the power n plus 1 upon. Please learn this formula. You will learn, mathematics students will learn this in mathematics, but biology student has to learn. There is no option. This much is required. You must learn all these things. Just like you learn tables, and when you learn table, you don't argue there what is the logic in learning the tables, and later on you understand what is the logic in learning the tables. So here W is equal to minus Q0 upon 4 pi epsilon 0 or integration x to the power minus 2 dx infinity to R minus Q0 upon 4 pi epsilon 0, or it is x to the power minus 2 plus 1 upon minus 2 plus 1 upper limit R lower limit infinity. You might have learned in class 11 while calculating gravitational potential. It is minus 1 outside, so it will become plus Q0 upon 4 pi epsilon 0. X to the power minus means 1 upon x. Actually, here x to the power minus 2 plus 1 equal to x minus 1 equal to 1 upon x. Simple. Don't get afraid of such operations of mathematics. These are simple things. Actually, our physics is blamed very difficult. No, physics is very simple, but so many things are there which you need to know to learn physics. And generally people keep on avoiding learning. Learning is a continuous process. I am a retired person. I have got retired in the age of 65 from the school and working continuously, and still I am learning. In the morning I forgot one thing and I could not. Well, I have done that. Then I see my previous notes, then I go to this was the mistake. तो वो होता रहता है, ऐसा कुछ नहीं है कि भाई आप पर नहीं होगा, होगा। एक बार करेंगे, दो बार करेंगे तो करना पड़ेगा। तो Q0 upon, have you got what the minus has gone? This minus 1 can be taken out, minus minus plus, or it is 1 upon R minus 1 upon infinity. 1 upon infinity, 0. You know it very well. So it is W upon Q0. Here Q upon 4 pi epsilon 0 into 1 by R. And W upon Q0 is V. So V is equal to 1 upon 4 pi epsilon 0 Q by R. Potential due to point charge Q at distance. Potential due to point charge at distance R is V equal to 1 upon 4 pi 0 Q by R. I think you have got my point. So I have derived here potential due to point charge Q at distance R. If this point charge is placed in a medium, if charge Q is placed in a medium, which medium? Insulating medium. Medium dielectric, not conducting, dielectric. I will explain just after the chapter what is the meaning of dielectrics and what is the meaning of dielectric constant. That will also be told to you. Then V come out to be 1 upon 4 pi epsilon 0 K Q upon R. If charge Q is in coulomb, R in meter, and this is 9 to 10 to the power 9. In vacuum you can 9 into 10 to the power 9 Q by R. So if Q is coulomb, R in volt, R in meter, then potential will be in volt. So this is the potential due to point charge Q at distance R. While calculating this work done, I have taken straight line. I have told you this charge Q produce electrostatic field. Electrostatic field is conservative. In conservative field, work done carrying body by a force does not depend on path followed. Does not depend on. So if I write here E dot dl, you know what is this? E the electric field which is the force per unit charge. So this is force on unit charge. dl distance or force into work done. So it will give, अगर मैं इसका इंटीग्रेट करता हूं तो दिस इज कॉल्ड लाइन इंटीग्रल ए टू बी. अगर मैं कहता हूं तो इट विल गिव बी माइनस बी ए, वी माइनस बी ए. ई डॉट डी एल इंटीग्रेशन फ्रॉम ए टू बी इज कॉल्ड लाइन इंटीग्रल. लाइन इंटीग्रल of magnetic field. Actually, in competitive exam, there are such things which students keep on neglecting. This simply E dot dl, force distance, work done per unit charge, potential difference. In our earlier video, I told you potential difference is the amount of work done carrying unit charge from one point to another. So line, the important thing which I want to tell you here is that line integral of electric field, you can note it here. Line integral of electric field is independent of path followed. So we can prove it other way, but we are not interested to prove here. When I learn a straight way, I can take path like this. A is here, B is here, and P is here. And मैं अगर यहाँ से ऐसा आता हूँ P here, if I choose the path this to carry the work done, the work will be same. So electrostatic field, please remember it, it's conservative force, and conservative force or conservative field are those in which work done in carrying body by a force or against the force, work done does not depend on path followed. If the work done by a force or against the force in carrying a body from one place to another does not depend on path followed, then that force or field is conservative. Please remember it. It is asked generally. In next video we will take very interesting topics. Thank you.